What is a reference frame? At first glance, it sounds like an abstract physics term, but in reality, reference frames shape how we understand motion, position, and even the nature of reality itself. Without reference frames, concepts like speed, distance, or direction would be meaningless. A reference frame is essentially a point of view from which motion and position are measured. It consists of a coordinate system and a clock, allowing us to describe where and when an event happens. Imagine you are sitting on a train moving at a constant speed. To you, the coffee cup on the table looks perfectly still. But to someone standing on the platform outside, that same cup is moving rapidly along the tracks. Both observations are correct because they are made from different reference frames. In everyday life, we usually rely on what's called an inertial reference frame. These are frames that are either at rest or moving at a constant velocity. Newton's laws of motion work perfectly in such frames. For example, a car cruising smoothly on a straight highway at constant speed can be treated as an inertial frame. Inside it, objects behave exactly as Newton predicted. However, things get more interesting when we consider non-inertial reference frames. These are frames that accelerate, rotate, or change direction. A classic example is a spinning merry-go-round. From your point of view on the ride, objects appear to be pushed outward by a mysterious force. This is not a real force, but a result of observing motion from a non-inertial reference frame. To explain motion correctly in such frames, physicists introduce so-called fictitious forces, like centrifugal and Coriolis forces. Reference frames become absolutely crucial in modern physics, especially in Einstein's theory of relativity. Einstein showed that there is no single, absolute reference frame for the entire universe. Instead, the laws of physics are the same in all inertial reference frames, and measurements of time and space can change depending on how fast you are moving relative to others. This means time itself can slow down, and lengths can shrink, all because of different reference frames. In simple terms, a reference frame is the invisible stage on which the universe performs. Change the stage, and the performance looks different. Understanding reference frames allows us to make sense of motion, forces, space, and time, and reveals that reality is deeply connected to how we observe it.